And then we can jump to points. Getting interesting, yeah. So this is still we are dealing with the point. I mean, can you tell me, anyone, what is the difference between point and vector? Yeah. I mean, depends. I think it depends, but in this case, the vector is just contain the essential information to describe something in the spatial context, and then the point here, the point is gonna occupy their own vector and color, right? So, for example, we have a point here, right? Yeah, and then point has a vector and color object. Yeah, that we already declared in the previous exercise. So let me zoom out a little bit. Yeah, a little bit more. Okay. So this is the vector class that we already visit, and then this is the color. I just copy paste from the previous exercise. Yeah. So this is just two code that we already visit, and then I create a new class called point. Yeah, and then as a value, it has a vector back as a back, and then color value as a color. Yeah, and then the initial value is the same as vector because this is required information for the creating a point, right? Okay, so inside of the constructor, I create a new vector, and then save this information inside of the back variable, which belongs to point class. Correct. And we have a distance to function, which is basically cooking the low level API, let's say. It's not low level, but what I'm saying is right now is because we have two different class, yeah, color and vector. And then I'm going to create a point class, right? And then I try to take advantage of two existing class, just like assemble these two class inside of the point, right? So this is a distance to function, set color function, get hex function inside of this point. Yeah. So let us look at the example, I guess. Yeah. So we have a point simply gives three number, and then all complexity is resolved inside of the class. We don't need to worry about it. And we have P0. I mean, I try to mimic the API in Rhino. Yeah, Rhino has the same function, distance too. Yeah, so one point has their instance function, and then the parameter is at the other point in order to get the distance between them. Correct. So this is actually if you do some Rhino Python or Rhino C#, there should be a exactly same function like this. Anyhow, so I create the 2 points and then measure the distance, and then also I will try to change the color using set color. What it does is there's a RGBA parameter that we need to input. I mean, this is required. So this number is a try to access this. This means this same context, the inside of the object, and then color. This indicate this value, right? Now we know, the color value has the other RGB, right? It's like a tree structure, right? So here, let me take a look at the color class here. It has an RGBA. I'm just trying to traverse the children's parents using the dot notation, right? So here, I basically directly overwrite the color value. Yeah. So now you can see what is the result here. Okay, so actually, you know what? The default value, you can see that what is default value here. Yeah, default value is RGB, meaning that this point is gonna be represented as a green color, right? But I'm just apply this number, and it's gonna be upside down, like FFR00 for green. For the blue, we have FF. Yeah. So we basically encapsulate the complexity based on different class. Yeah. We basically, let's say, isolate the problem. Yeah. I think this is really important. Modularize the functions. Let's say. Okay, we can jump to other example. We have a line here. So actually, what I did is I directly import the previous exercise because I don't know, the code pen support it. So I just import it. So I just actually use the point that we just made, yeah. And then because we know you can define line by 2 points, right? So this is the point, and then we directly not override, like a declare the point, and then we have like a get midpoint function. I just implement it. So now for the use case, I created 2 points. Yeah, this is just like independent points. Yeah, and then here is a line because the line needed 2 points. Yeah, and then I just create the object out of this line class, and then actually we can re-execute. Come on, we are busy. Okay, let me open the developer panel. Yeah, so okay, this is the, I think that this is the line 39, this one, yeah. Okay, no, this one, I guess, yeah. So we have a point here, yeah, and the point, oh, what is this? Okay, sorry, here, line, yeah, line, this is line. So the line contains 2 points here, yeah, because the class has 2 points here, right? And then individual point has a color here, yeah, RGBA, it has a vector, XYZ, right? And then the other point is a 10255 as a color value, and then vector 555. So we have the line object, but basically we can try to inspect what is this. It turns out the line has 2 points, yeah, that we already declared in the previous the exercise, like a point. Do you guys can see my point, right? How we organize the class, and we can take advantage of create our own design algorithm or the object or class. So anyhow, and then as I said, I implement like a get midpoint function here, right? So actually this point is the middle point of this line. We have, let's say we have 2 points. Where is midpoint? Come on, this is the midpoint, right? So we have a 0, 0, 0 and 5, 5, 5, and the midpoint is going to be like that. 2.5, 2.5, 2.5. Does it make sense? Right? Come on. Maybe we can make a little more like this. Yeah. So is it execute or now? No, not yet. Come on, we are busy. Okay, save it, refresh it. So this is the middle point. What? Where are you? Color. Oh yeah, here. Very good. Point. Vector. This is actually the represent midpoint of this line. Yeah. So let me jump. We have we are reach polyline here. So I guess you guys are smart, enough smart to predict how we build polyline class because we know how to assemble or disassemble the individual blocks, you know. So here we have a polyline, and then we have point list inside of polyline class, yeah. And then maybe as an input parameter, we can, you know, reuse polyline for the polygon, you know, by just using take advantage of, you know, the is open Boolean variable. If it's open, we are not close the polyline. However, if it's closed, is open is true, then we try to, you know, force to close the polyline. Then it becomes polygon. Does it make sense, right? So I put the add the internet function, right? And then toString and get length. Yeah, this is the function. Just to think about like what is input and what is the output. There's no return value here. However, it has a return, right? So now I create the just empty polyline because, oh, this is my bad, sorry. This is good. I mean, there's no error. But as I said, explicit way is always best. So I just give it the default value here. So this is good to go. And then the input value, in order to execute this function, the input value is point, right? So that's why I directly make the point here as a new key, with new keyword, right? So I'm keep adding 4 points, yeah, and then I using the execute toString and then get length function, which belongs to that object, particular object here, not the class, yeah, because this is not an static function. Anyhow, what is the result here? Okay, so if you use the toString here, toString, yeah, it returns the length of the points that polyline has. Makes sense, right? That we append the 4 points, so that's why we see the 4, right? And then this is actually total length of the points. Yeah, very simple because you know out of this point we can make some the distance. Like okay, so let me try to take this one a little bit. Okay, so here's the magic, not magic, but we have a loop, right? However, we are not going to loop through all the way the end. Just write one before the end, because we're gonna try to measure the current ID with the +1. Yeah. So can you see my screen? Like can you see my hand? So we have a 1 point, 2 points, 3 point, 4 point. So this point compare this one, and then this point compare this one, and then this point compare with this point, so that we can loop through all the points, so that we can just sum them, and then return the value, so that we can call it total distance. Correct. Let me jump, and then polygon here. To be honest, I'm a little busy. I couldn't sleep. Yeah, so I'm leave this exercise for the homework for you guys. Okay, so please copy this card. Please copy this card to your code pen, and then try to make a polygon. You guys own custom polygon, which is just some simple mathematical object. The reason I'm emphasizing this one is it has nothing to do with platform. It has nothing to do with the WebGL, OpenGL, or 3JS, or Canvas, or Rhino, or processing. Yeah, you can actually implement the lines of code to whatever platform, as long as you can script, because this is a simple mathematical object, right? You can implement this onto, I don't know, Python or MATLAB or processing or Rhino Python or Rhino C#. Yeah,